Midsegment theorem. This, you will notice, is only one side. We're going to breeze through this like the cool, brisk fall air that is outside.
It's nice and warm outside.
It is nice outside. And then we are going to move on to the next worksheet, which will be taught halfway through. Like, I'll teach one of each type of problem, and the remaining practice problems are your practice assignment that's due tomorrow. This has a vocab word on it that you need to know. Mid-segment. Mathematicians used creativity to name things in a manner to help you remember what it is. It is a segment connecting the middle of something. Mid-segment. You with me? If something's in the middle, it's cut into two equal parts, right? Okay, so if you look at this picture up here, this is the progression of drawing all three mid-segments in a triangle. If you look at the first triangle, they have simply found the middle of that side. Then in the next triangle, they have found the middle of the remaining sides. Then in the next triangle, they have connected the middle of the left side to the middle of the right side, which creates the mid-segment. Then the final triangle is showing you what it looks like when all three mid-segments have been drawn. It's really weird, like a triangle embedded within a triangle but upside down. But this is all three mid-segments drawn. When you have a mid-segment of a triangle, number one, you're looking for two things. First, it needs to be the midpoint from one side connected to the midpoint of the other side. The way you know it's the midpoint is if it has these congruent marks to show that, hey, that just split that in half. And then over here, these congruent marks to show, hey, it split that side in half as well. So those are midpoints. The second thing that has to be there, do you see these little triangle notations? Do you know what they mean? You should. We talked about it. This means, sounds like everybody needs to write it. This means parallel. Oh, duh. It means parallel. When the base of a triangle is parallel with the, I call it the base, like the bottom of that smaller triangle, you see the smaller triangle in the top? When those two pieces are parallel and that middle line is connecting midpoint to midpoint, you have what's called the mid-segment theorem. All right, and what does it mean? It means that the big triangle, the big one, is exactly double the small one. Or, if we went in the reverse direction, the small triangle is exactly half the big triangle, which is what goes right here. And it's half the length of the third side. Let's label your picture. This right here is the actual mid-segment. And this down here we are calling the base. You do need to look for the four congruent sides. Look for the four congruent sides. Now, they don't have to all be congruent to each other, but like those two need to be congruent and these two need to be congruent, okay? When you know you have a mid-segment in front of you, there are two ways to set it up. There's two ways. One is more ideal than the other. I'm sure you're going to be able to determine which one that is. Let me show you the both ways, and then you figure out which one you like. One way one way is half the base will give you the midsegment. If you take the base and cut it in half, it'll give you the length of the midsegment. That's one way to do it. Now, raise your hand if you like fractions.
No.
Exactly. So if I don't want to deal with cutting things in half, because a lot of people are not a fan of fractions, what would be the opposite equation? Do what? Multiply the midsegment by 2, and I would have the length of the base. So if you look right here, if you just multiply 2 to the other side, 2 times the midsegment, that is the other way to set this up, and that is the way that most people prefer. Now, when we start these problems, and including the ones we're going to on the next sheet, write this somewhere. I want you to remember this phrase. Go to what you know. Do not yell at me that you don't even know how to start this, because the first thing I'm going to say to you is, well, what do you know? What do you know in the picture? So like number 7, I'm sorry, they don't start at number 1. Number 7. I did this just to throw anyone's OCD off, including mine.
Oh,
It's killing me. Can we just move through it, please, quickly, because it's killing me. Number 7, go to what you know. What do you know in the picture? You know the bottom is 18. Now, I've said before, don't just look at the picture and go by looks, but when we're dealing with triangles like this, you can go by looks. 18 is on bottom, so clearly has to be bigger than the segment marked with an X, right? Okay, so if 18 is the bottom, and this is a mid-segment problem, then this has to be 9. That's it. All right, go to number 8. 2. 2. Go to number 8. Go to what you know. You know the mid is 12. Then that means the base would be 24.
She's just in the bathroom. She just went to the bathroom.
She's not here. Thank you. Yeah. My jacket. My shirt. Yeah. Go to number 9. Go to what you know. What do you know? You know the 84 is the base. Use the vocab. The base is 84. So if the base is 84, then the mid would be 42. You see how you found that? Label it, and then there's your equation. So 3x equals 42. Divide by 3, and what do you get? Make sure everything I write, you write. There's some stuff missing. Number 10. Go to what you know. You know the mid is 4. So then the base would be 8. And that's what you set it equal to. Solve that. So what do we equal 2? Right? Yeah. That's 8. What's that? Yeah, the base is 8. Alright, when you solve that, what'd you get? 2. Go to the next one.
I don't know.
Yeah, you do.
It's x plus 20 equals x minus plus 30.
Oh.
Wait, what is it? X plus 20 equals x plus 30.
No, that's not right, Eddie.
That's not right.
Hey, hold on. Don't forget I'm recording, so let's don't mess up the video.
Wait a minute. What if we do x plus 20 equals x plus 30? And then you get.
Now, are they equal?
No, but listen.
I know where you're going with it, but if you're setting them equal and solving, then you're not going to get the right answer. Are they equal? No. One of them gets double to equal the other one. Which one should you double?
Oh. Wait, what? What was the question?
One of them needs to be doubled to equal the larger one. It would make sense to double. Thank you. I heard it. I'm just waiting for more people to come to a consensus.
Sorry, I'm not.
Double the mid to equal the base. You would not double the base. It's already the bigger side, right? So double the mid to equal the base and set that up. You will need to put parentheses around them because it is a binomial. So set it up. Set it up. I want to see what comes out of your brain when you put, well, and that's a problem. We need to work on that.
Hey, do you look at what I do?
Yeah, I'm coming. I'm pretty sure you have the right answer. I'm waiting for everybody to try it on paper before I put it on the board. Double the mid to equal the base. Find the mid segment. You're doubling it to equal the base. Nope, that's not double. That's squaring it. Double. Why are you erasing the whole thing? Don't erase the whole thing. Oh, I got it. Double means to what? What? Now, if you double something. There you go. Thank you. You got this. All right, now double the mid to equal the base. Why are you going underneath? Oh yeah, no, don't do that yet. Come over here. Finish your equation. What would it be equal to? What's it gonna equal? What's the base? Now solve that. Distribute the 2. Did you get negative 10? Well, you're welcome. Distribute that 2. Then solve. Alright, so if I double the mid to equal the base, I have to distribute the 2. Shh. Now I have free choice on what you have to distribute.
Oh.
Now I have free choice on what I'm going to move. I personally move x terms first, numbers last, and I also tend to move the variable with the smaller coefficient because then I have less negatives. So I'm going to move that one to its like term, which feels weird because now it's 1x, but it's okay, it's doing it right. Then I'll subtract 40 and I end up with x equals negative 10. Now you should look at this and think to yourself something's wrong. Why should you think at first something's wrong? Because it's negative and we're talking about the length of sides. But go to the picture. Was this just a plain old x? No, it was x plus 30. If it had been a plain old x and I came to a negative, am I right? No. That's your clue that something's wrong. but it's not a plain old x, it's an x plus 30. No clue what's happening there. So plug negative 10 in. What do I get when I plug negative 10 in here? I get 10. What do I get when I plug negative 10 in there? Does that make sense? Yes. No, I think it's just, it kind of disappears. It's still recording. Thank you. All right, go to the next one. Don't ask me why, but there is another 7. I don't know why. I don't know what I was thinking when I made this. But anyways, y'all with me? Have I lost some of you? Because y'all, this is going to be on the test. Y'all, if your phone's out or if you're on something else or if you're asleep, if you could wake up and join me. That'd be great. Look at this next one. It says points X, Y, and Z are midpoints. That means it's in the middle. Y'all with me? So Z's in the middle. X is in the middle. Do I need to do that? Do I need to put the same tick marks? No, I need to put different tick marks because I don't know that those are necessarily equal from side to side, right? Yeah? Y'all writing? And then this one is in the middle. Number 7 says YZ is this, MN is this, find YZ. There's a lot going on in this picture. Yeah, I would recommend drawing it separately, drawing it different, like where there's not as much going on, and I would only focus on YZ and MN. So I'm going to sketch that same picture, but I'm only going to draw a YZ. Where's YZ? Right here. Right here. And MN is here. Now it doesn't look as crowded. And now I can label it. What is YZ? 3x plus 1. And what's MN? Doesn't that look a lot easier? So good. It's the same thing. Now solve it. Which one gets doubled? Mid. Mid gets doubled. And that would be which one? 3x plus 1. Please try it. Please don't wait for me to put it on the board and then you write it down. Please try it. Double the 3x plus 1 to equal the 10x minus 6. What did you get when you solved it? Something's wrong.
I'm not going to. If you do
You forgot to distribute the two. It helps to draw. I want you to draw the arches. No, wait.
Yeah. You're not going to play I was smacking.
Draw the arches. And hey, look at me. I still draw the arches sometimes to remind myself, okay, I got to go to all of this. So draw the arches. It might help. All right, did you get 2? Did you get 2?
Yes.
I subtracted 6x, and then I added 6. And does the question ask me to solve for x?
No, so you have to put it in.
Did you finish? Okay. Yeah, when you go and plug 2 in, you should get 7. Go to the next one and do it. Huh? You still have to solve for x on the next one. Redraw it. Draw it again so it's not so crowded.
How do we get 7?
You have to plug it back in. You got to plug this x into yz. YZ right here. 2 is going to go right there. So 3 times 2 plus 1.
I think they were talking about the number of like the.
Oh,
no.
y'all, I don't know. There's no telling.
No, you answered it right.
I thought it was answered.
I've already fixed it for next year, so it's just to let you know so that you can rest assured. The group next year won't have to deal with it. Yeah, that's great.
You have to deal with what?
You're welcome. Whenever I'm making stuff, it's like the first year is always where I make mistakes because I just get excited like, oh, this looks so good, I'm done. Print, run, copy, press, run to press. What it was is it used to be the back side of this. I was going through 6. And this was a lot. And I was like, okay, we'll separate them. And I made 2 documents.
So
you said change it. Now, why that ended up so big, I still don't know. Yeah. Were you scared late? You have to label it.
You do the
Why do you get this here?
So I just felt like so that next year's not rough, because Lord knows I won't remember.
I'm 2016.
You know what I mean? If it's something I can fix quick, I fix it and I reprint it.
Like
If
you
it's-
have all the papers.
Yeah.
That's fine.
Well, I'm working on it. Yeah.
Do you know how many students you're doing?
You all can you see that?
I remember the day.
Lazy.
Yeah, a lot of them.
All right, YX is here. MO is here. Did you get X is 5? Finish it. Make sure you're going to get X is 5. Now, if X is 5, then what's the length of MO? Make sure you've got that.